So if we observe this figure, so this is what the kit that you will be using in your part B experiments. Okay. Uh, so if you just observe here, what we were discussing in the module 3. So in order to design any of the embedded systems, the important thing what we have discussed at the starting about the core. So if you want to design any of the embedded system, you have to make use of the core, either a microcontroller or a microprocessor or FPGA or ASIC. So based on the application, so you have to choose the core for your embedded system. So the core for this whole kit, the core for this whole kit is nothing but the ARM processor. So that is represented by LPC2148. Okay, the IC for this, the IC number or the name for this ARM processor is what? LPC2148. So that is what I have written in the first slide. Okay, LPC2148 ports. So today we will be discussing about the ports related to LPC2148 and how to handle those ports by filling some contents into the registers. Okay, so LPC means the low power controller. Okay, and the name and the full name or the full IC name is LPC2148. So if you just observe here, this is the LPC214X. Okay, this figure is LPC214X. There are various series, but right now we are discussing about LPC2148. And the number of ports remains same for all the series. Okay, the number of ports or the number of pins. Okay, the number of ports are also called as pins. The number of ports remains same for all the series here. Okay, so how many pins or how many ports are available for LPC2148? It has 64 pins arranged in quad inline package. So it is arranged in the quad inline means, so the pins are arranged in all 4 directions. That's why it is quad. This is an IC. So it is arranged in all 4 sides. The ports are, the pins are deployed in all 4 directions. So if you just observe the ICs like AND gate, NOT gate, so the pins are deployed only in the 2 directions. Okay, the pins which are deployed in all the 4 directions are called as a quad inline package. Okay, is the first point clear? So LPC2148 is the core that we are using in our kit, and it is having how many pins? Totally 64 pins are there. And why it is called quad? Because pins are available from all the 4 directions. Hence it is called quad inline package. Next, so among 64 pins, the 48 are GPIO pins. So if you just observe or if you just recall the ADE lab, so few pins we were not using, right? If you have used the 555 timer or if you have used the 741 op-amp, so few of the pins we were not using it, right? So similarly, in this LPC2148 also, among the 64 pins, we are not using all of it. We are using only 48. Only the 48 pins are given control for the user. So rest of the pins are not being controlled by the user end. So that is what they are telling in the second line. So among 64 pins, 48 are the GPIO pins, and 48 can be used or can be used either as an input or output pins. What is this GPIO? So GPIO means a general purpose input and output. So among 64 pins, only 48 pins can be used as a general purpose input and output. So rest of the 16 pins, we don't know. We are not using it. It is left to the manufacturer or the designer. We are not making use of it. Okay. Coming to the third point, it has a 2 ports, namely P0 and P1. Okay. So how many ports are there? There are only 2 ports, that is P0 and P1. So P0 has how many pins? 32. And P1 has how many pins? Of course, the P1 is also having 32 pins. So port 0 is represented as P0.0, P0.1, P0.2, P0.3 likewise till P0.31. So totally 32 pins are available from port 0, and from port 1 we are making use of only the higher level pins, that is from P1.16 to P1.31. And what about the rest of pins, that is P1.0 till P1.15? So those pins we are not utilizing it. As I have already told you in the second step, only 48 pins are available for the user end or for the designer. Among 48, 32 are captured by port 0 and rest of the 16 pins are captured by port 1. And what about port P1.0 to P1.5? We are not utilizing it. Okay, so that is what the lower pins are not usable. What are the lower pins? Lower pins are nothing but P1.0 to P1.5. But in the case of port 0, all pins or all ports, that is from P0.0 to P0.31, the lower as well as the higher pins are usable. Okay, port pins P1.15 to P1.0 are not available for the user. So 32 pins are available from port 0 and 16 pins are available from port 1. So totally 48 pins, right? That is what I have written in the second step. So totally 48 pins are available for the user. Okay, I'll just repeat it once again. Those who have joined late. Okay, so this is the core of the kit, that whatever we are using in the part B experiments. So this core is nothing but the ARM processor, which is denoted by the name LPC2148. And this core is a quad inline package. Why we are calling it as a quad? Because the pins are available from all 4 directions. And how many pins are there? Totally 64 pins are there. And among 64 pins, we are having the control over only 48. And the remaining 16 pins, we are not utilizing it. Okay. So how we are giving the names to these pins is P0.0 till P0.31 are the names given to the pins with respect to the port 0. And port 1 will be holding the names as P1.16 and P1 till P1.31. So if you just observe here, so port 0 pin starts from P0, okay, and this is the numbers as usual, and port 1 pin starts from P1, okay, this is P0 and this is P1. So what I can call this pin as, I can call it as P0.0. What I can call this as P0.1. What I can call this as P0.2. This as P0.3. So likewise, I will be calling the names. I have given the names for each and every pin, and each and every pin belong to either port 0 or port 1. And of course, we are not using the lower end pins, that is P1.15 to P1.0. That is the lower pins, we are not utilizing it. It is not given for the user control. So till here it is clear for everyone. Do you have any doubts with respect to the points that whatever I have explained till now? Please do reply.
Yes, sir.
Shall I move on to the next slide?
Yes, sir.
Yes, sir.
Okay. So now 48 GPIO pins can perform other functions also. So whatever the 48 pins that were made allowed to use by the user, it is not only used for the general purpose input output. You can also make that pins to work as a transmitter or receiver. You can also make those pins to work as a transmitter or receiver, or you can also make those pins to work as a pulse width modulation, or you can also make those pins to work for external interrupts. Okay, whatever the 48 pins that were given control for the user, it is not only made used for general purpose, but it also performs these type of functions, that is transmitter, receiver, pulse width modulation and external interrupt. But in our syllabus, we are not making the pins to work for these functions. Okay, we are working the pins with respect to GPIO only. We are making all the pins to work for general purpose input output functions only. We are not making the pin to work as a transmitter. We are not making the pins to work as an external interrupt or pulse width modulation. So hence we shall not discuss about these functions in detail. So we'll be discussing only about the first function. So now if I want to make the P0.0 as a general purpose input output, I have to use the bits 0, 0. If I want to make this bit to work as a transmitter or a receiver, I have to give the bits as 0, 1. If I want to make this port or this pin to work as a pulse width modulation, then I have to give it as 1, 0. So if you just observe the left hand side, how many bits I'm utilizing in order to represent a function? I'm utilizing 2 bits. So 0, 0 means it works as a GPIO, 0, 1 means it works as a transmitter, 1, 0 means pulse width modulation, and 1, 1 means external interrupters are not defined. Okay, but according to the syllabus, what I have told, you have to make or you have to use the pins only for GPIO. So therefore, what you will be loading always, you will be loading always as 00 only. Understanding? And one more questions to all of you. So why I have used only 2 bits? Why I am not using 3 bits or a single bit? Can anyone answer? It's a very simple answer. Why I'm using 2 bits for one function? Why I'm not using 3 bits? I can use 000, right? I can use 4 zeros instead of 00. Why I'm using only 2 bits for representing a single function? Whether you have got my question? Anyone from the class? Why am I not using 1 bit or a 3 bit or 4 bit for representing? I'm using 2 bits here. Why?
So because we have 2 ports.
No.
Sir, in a memory location, only 2 bits can be stored.
Yes. No. Okay, I'll just give a simple hint for you. So for 4x1 mux, okay, for 4x1 mux, how many select lines will be there?
2.
How many select lines will be there? For 4x1 mux, it is 2, right? And for 8x1 mux?
3.
Yes. Now, did you got the hint? How many functions are here?
4.
See, if there are 4 functions, obviously I require to go for a 2-bit representation. If there are 8 functions, obviously I have to go for an 8-bit representation. If there are 16 functions, I will go for a 4-bit representation. So you got to know why I'm using 2 bits now, right? See, if I'm going for a 3-bit representation, okay, just assume I'm going for a 3-bit representation. So 0, 0, 0, okay, 0, 0, 1, and 0, 1, 0, and 0, 1, 1, and 1, 0, 0. Likewise, you will be writing till 1, 1, 1. Of course, only 3 bits, only 4 functions are there, and the rest of the representation will not be used. So therefore, I am not going for the 3-bit representation. I am going only for the 2-bit representation. And since my functions are only 4, is it clear now?
Yes, sir.
Okay, fine. So now, if I want to make my port P0.1 as a GPIO, again, I will be loading 00 only. I have explained with 2 examples, that's all. If I want to make any of the pin from any of the port, I will be making the bits as 00 if those pins has to work as a GPIO. Okay. Next, to define the function of a 48 pins, we require how many bits? We require 48 into 2. So see here, in this first example, if I want to make this port 0.0 to work as a GPIO, how many bits I'm using? 2 bits. If I want to make 2 pins to work as a GPIO, then I require 2 plus 2, that is 4 pins. If I want to make the 3 pins to work as a GPIO, then 2 plus 2 plus 2, you require 6 bits, right? Similarly, to define the function of a 48 pins, we require 48 into 2. Why this 2? Because the number of bits length. Okay, so 48 into 2, you require 96 bits. Totally, you require how many bits? You require 96 bits in order to make all the pins to work as a GPIO. Understood? So I hope the second slide is also clear. Shall I go to the third slide?
Yes, sir.
After each and every slide explanation, I will be asking you whether can I go to the next concept or not, because each and every slide is interconnected to the next. If you haven't understood the first or second slide, then you will not understand the third slide. So please tell me now itself whether you have understood or not. If you have understood, I will be moving on from here. It is very important from the third slide. I expect the answer in the chat box. So shall I move on to the third slide, or do you want me to repeat it again, the first 2 slides? Yes, yes. Okay. So this says how many of you are present in the class? Conscious. Okay. Many are giving the answers. Very good. Fine. Okay. Thank you all. Fine. So from the third slide, okay, it is a very important. We'll be discussing about the registers. Okay. So LPC 2148 has 3 registers. So those are pin select registers. So pin select 0, pin select 1, and pin select 2. I want all of you to write down all these things. So LPC 2148 supports how many pin select registers? It supports 3 pin select registers, which are named as pin select 0, pin select 1, and pin select 2. Okay, and you shouldn't give other names like pin select 1, 2, 3 and all. You have to use these names only. That is pin select 0, pin select 1, and pin select 2. So now each pin select register is of 32 bits in its size. So as we were discussing from the first class of MES, all the registers that whatever we have dealt, or whatever the registers that we were dealing is of 32 bits only. So even this pin select registers is also of 32 bits. So now 32 bits are being provided from one register means, so 32 plus 32 plus 32, how many? It is 96 bits, right? So what we have discussed in the previous slide. So to define the functions of 48, you require 96 bits. So those 96 bits are the 96 capacity is available from these 3 registers. Okay, if you want to define any one port or any one pin, you have to make use of these registers. Okay, so now we will be going in depth. So pin select 0 is used to define the function for port 0. So how many ports are there? You all know that there are only 2 ports, that is you have only 2 ports, that is port 0 and port 1. From port 0, you are utilizing all the 32 pins, and that is represented as P0.0 to P0.31. I'm going very slowly because these concepts are very new and very important. And from port 1, we are utilizing only from P, okay, P1. This is represented as P1.16 to P1.31. Okay, the lower end pins of port 1 are not used. Okay, so pin select 0 is used to define the port pins, that is from P0 to P0.15. So now pin select 0. So pin select 0, pin select 0 is used to define the function of the pins only for the lower end, that is only from P0.0 to P0.15. And from P0.15 to P0.31, sorry, P0.16 to P0.31 is controlled by pin select 1, and P1.16 to P1.31 is being controlled by pin select 2. So don't be confused, it is very simple. So port 0 list pins there. So totally 32 pins are there, which is represented as P0.0. This is P0.1, P0.2. So likewise, I have represented till P0.15. So these are considered as the lower pins of port 0. Okay, come to the second line here. So P0.16, P0.17 till P0.31 I have written here. And P0.16 to P0.31 are called as higher level pins. So this is lower level pins and this is higher level pins of port 0. So the lower level pins of port 0 are controlled by pin select 0. Okay, pin select 0 is used in order to control the lower end pins of port 0, and higher level or higher end pins of port 0, that is from P0.16 to P0.31 are controlled by pin select 1. And pin select 2 is used to control the higher level pins of port 1. See here, P1.16, P1.17, P1.18 till P1.31 I have written here. Okay, and these pins are controlled by pin select 2. And as I was telling you that each and every pin will be making use of how many bits? 2 bits will be used. That is 0th and 1 will be used by P0.0 and P0.1. The pin number P0.1 will be controlled by the bits 2nd and 3rd of pin select register 0, and P0.2 pin will be controlled by the 4th and 5th bit of pin select 0. Similarly, P0.8 pin will be controlled by 16th and 17th bit of pin select register 0. Understanding? Have you all understood these 3 parts?
Yes, sir.
So now I'll just very randomly ask the question. So if P0. Okay, P0.18 has to be controlled, means which register you'll use?
Pin select 1, sir.
Pin select 1. And what are all the bits that are concerned with respect to P0.18? What are all the bits controlling this P0.18?
30.
Yes, yes. Yes, anyone? It is available on the sheet itself. Okay, just look P0.17, and what will be the next bits that will be controlling this P0.18?
4 and 5, sir.
4 and 5. Yes. 4th and 5th bit is responsible for controlling the P0.18. Okay. Okay, very randomly I'll be asking one more point, that is P1.23. So if you want to control this pin, so which register you'll use?
Pin select 2, sir.
Pin select 2. And which bits are responsible for controlling this port? I mean the pin.
15 and 14, sir.
17 and 16 for 24. 15 and 14 for 23. Very good. It's correct. Okay. I hope you have understood this. Okay. So that is what I have written. The pin select 1 is used to define the function for P0.16 to P0.31, and pin select 2 is used to define the function for the port 1 pins, that is P1.16 to P1.31. Okay, very fastly we'll have the summary, whatever we have discussed till now. Okay, so what kit we are using? We are using the ARM processor kit. So in the ARM processor kit, many things will be available here as shown. There are 7-segment display, there is an LCD display, and there is a matrix keyboard here, and there are some switches available, and there is some relay over here. So likewise, many peripherals are being connected to your processor, that is LPC2148. So how many pins are available for LPC2148? It is 64, and among 64 only 48 is under our control, and you can make these pins to work either as a GPIO or a transmitter or receiver or a pulse width modulator or a external interrupt. But according to the syllabus, we have to make use of all the pins as a general purpose input output only. So since there are having 4 functions, we are using 2 bits for our representation. Okay, since we are using the 2 bits for our representation, we require 48 into 2, that is 96 bits are required. Since 96 bits are required, 3 registers are being provided from the ARM processor, namely pin select 0, pin select 1, and pin select 2. So pin select 0 is responsible for controlling the pins from P0.0 to P0.15, and pin select 1 is responsible for defining the function for the higher level port 0 pins, and pin select 2 is responsible for defining the functions for the higher order level pins of port 1. Okay, by keeping all these concepts, we will be moving on to the further concept, that is direction register. So before going to the concept of a direction register, we will solve some simple problems. Actually, that I have to give it as an assignment, but anyway, we will be discussing now itself. Okay, so to make P0.0 to function as a GPIO, which pins you are making, which pins you have to make it as a 0? Which pins you have to make it as 0? See here, assign the 0th bit and the first bit of pin select 0 to 0 and 0. Okay, understood? So why I'm giving 0, 0 here? Because I want to make those pin to work as GPIO. One more question. If I want to make P0.2, if I want to make P0.2 as GPIO, then what will be your pin select? What will be your pin select 0 contents? Think and give the answer. To which bit position I have to load 0, 0? To which bit position I have to make 0, 0 in order to make this P0.2 work as GPIO? Shall I go to the previous slide so that it will be helpful? See, I'm asking, if I want to make a port 0.2 as GPIO, which bits you will be making it as 0, 0?
4th and 5th, sir.
4th and 5th of which register?
Pin select 0.
Yes, 4th and 5th bit position of pin select 0, you have to make it as 0, 0. Okay, fine. So to make port 0.0 to function as a GPIO, okay, I'm making the 0th and the first bit of pin select as 0, 0 respectively. And if I want to make port 0.0 to function as a transmitter, you want to load 0, 1. We have discussed here, see. 0, 1 for transmitter, 0, 0 for GPIO, and 1, 0 for pulse width modulator. Okay, so to make port 1.16 to function as a GPIO, to make port 1.16 to function as a GPIO, you have to assign 0th and first bits of pin select 2 register. Okay, it is pin select 2 register to 0 0. Whenever GPIO comes, very blindly you can write it as 0 0. And to make P0.28 to function as a GPIO, you have to assign the 25th and 24th bits of pin select 1 to 0 0 respectively. Okay, so if you understand the concepts with an examples or an assignment, then only it will be very easy. Okay, I hope you have understood. So based on that, we will be moving on to the next type of a register, that is a direction register. So as the name itself specifies, so you are controlling the direction of the pin. Okay, so this direction register will be controlling the direction of the pin. So direction of the pin means either you can make the pin to work as an input port, or you can make the port to work as an output. So if you want to make the port to work as an output, you have to load some bit. If you want to make the port to work as an input, you have to load another bit. So we will try to understand. So these registers, okay, these direction registers are used to set the direction of the ports. So in order to set the direction, we have to choose the registers called the direction register. In other words, to define the port pins either as an input or either as an output, we have to use these registers. And what are the names given to this register? It is IO, it is not 10, it is IO. Okay, please write down here. It is IO. IO0 DIR and IO1 DIR. Okay, it is IO0 DIR and IO1 DIR. So till now, what are all the registers we have got to know? The different register we have got to know about pin select 0, pin select 1, pin select 2, and we have also got to know about DIR, IO0 DIR and IO1 DIR. So why two registers are required here? So it acts as a direction register for port 0. So one separate register is there for controlling port 0, and another separate register is there for controlling port 1. Okay, why here only two registers? Why not 3? In the previous type of registers we have discussed about 3, that is pin select 0, pin select 1, pin select 2. But here we are discussing only 2 registers. Why? Why? Because in the previous case there were 4 functions. Okay, you can make the pins to work either among the 4 functions. So for choosing choosing one particular function, we have to make use of the 2 bits there. But here there are only 2 options. Either you can make the pin as a input pin, or you can make the pin as an output pin. So therefore there is no need to go for a 2-bit representation. A single bit is enough. So therefore we are sticking on to the only 2 register, that is IO0 DIR and IO1 DIR. So if you want to make the pin as an output pin, you have to load one with the concerned or to that respective bit position. If you want to make a particular pin as an input pin, you have to load the respective bit position as 0. Remember, this is very important. Output means if you want to transform the pin to output, you have to load 1. If you want to make the pin as an input pin, you have to load 0 to the respective position. So where you have to load, I'll tell you. Okay, fine. So to make all the pins of port 0 to operate as an output pins. So output pins means what? Sorry. So output pins means what? You have to load 0. Sorry, you have to load 1. If you want to make the pins as an output pin, you have to load 1. If you want to make the pins as an input pin, you have to load 0. And IO0 DIR is responsible for controlling port 0, and IO1 DIR is responsible for controlling port 1. So now what is the question? So to make all the pins of port 0, so to operate as an output pins, which register you'll use? You'll use obviously IO0 DIR, because we are discussing about port 0 here. And You all know that the registers, whatever we are discussing, is of 32-bit. So each and every bit position in the IO0 DIR is controlling each and every pin. If you just observe here, the last bit position is controlling P0.0 of port 0, and the first and this bit is controlling P0.1, and this bit is controlling P0.2, this bit P0.3, P0.4, P0.5. Likewise, what is this bit is controlling? Can anyone tell? So this bit is controlling which port, which pin? Yes, it is very important to answer in order to move on to the further examples. The last bit is controlling which pin, I am asking. Is it audible for everyone?
31st pin, sir.
Yes, very good. The 31st pin of port 0 is being controlled by this bit. Okay. So now if I am writing in the hexadecimal format, okay, these are all in the form of binary. If I convert this to hexadecimal, you will get it as 0xFFFF. So this data should be loaded into IO0 DIR in order to make all the pins of port 0 to operate as an output port. Okay, the same thing if you want to operate as an input port, what we have discussed. If you want to operate it as an input, you have to make it as 0, right? So that's why I have loaded with zeros here. If I'm loading all the bit positions with 0, it means that I'm making all the pins of port 0 to operate as input ports, right? Is it clear? So what I'm loading into IO0 DIR, I'm loading 0x, 00, 00, 00 and 00. Understood? Now we will understand the further examples, which is more specific. So example, to make P0.0 to P0.3 of port 0 to operate as output pins. Okay, they are specifying only the port numbers or the pin numbers, that is only from P0.0 to P0.3 I have to make it as an output pins, and rest of the pins, that is P0.4 to P0.31, I am least bothered about that. So what data you will load it into IO0 DIR? First of all, the register you have to name it, whether you will be choosing the IO0 DIR or IO1 DIR. So you have to choose IO0 DIR if you are dealing with port 0 pins. If you are dealing with port 1 pins, you have to choose IO1 DIR. And what is the question? You have to make the pins, that is P0.0 to P0.3 as output. So the last 4 positions, right? The last 4 positions will be controlling this pins. So therefore only last 4 positions I have to make it as 1, rest I have to keep it as 0, because only the last 4 pins they are trying to make it as an output pins, and the rest pins we shall not bother about it. So therefore I have kept it with zeros, and the last 4 positions are loaded with 1. So therefore you are loading what? 0x, 0000, 00 and 0f. So 0f is loaded into the IO0 DIR in order to make P0.0 to P0.3 to work as an output pins. Okay. So a simple question to all of you, you can answer in the chat box. So example, to make a P 0.4 to P0.8. Okay, P0.4 to P0.8 of port 0 to operate as output pins. Okay, I want answer in the chat box. If I want to make P0.4 to P0.8 as an output pins, what data you will load? in the register? Yes, all of you can give the answer in the chat box soon. I'll wait for a minute. Think. Akshay, you have to convert the data into hexadecimal. So your thinking is correct, but you need to
Okay.
convert the data. Very good. Abhay and Ishika, answer is correct. See here, P0.4 to P0.8 means 4th bit, 5th bit, 6th, 7th and 8th. So therefore you have to load 5 ones here. If you are converting into hexadecimal, it is 1F, right? So 1F0 has to be loaded into 0x, sorry, 1F0 has to be loaded into DIR register. Which DIR register? IO0 DIR register. Because we are talking about the port 0. And what about others? Only 4 students are active. What about others? See, all of you are getting, or simply I'm just going like that? Are you feeling difficulty in understanding the concepts? Do you want me to go still slower? Tell something. Are you all understanding? Only four answers I have got.
Understood, sir.
Shall I move on?
Yes, sir.
Yes, sir.
Okay. So the last example, what they're talking all about is example to make only P0.1 of port 0 to operate as output pins. So they are very much specifying, they are very much specific here. So they want to make only a single port or only a single pin, that is P0.1, to work as an output pin. So therefore it is 1 here. And you are supposed to load what? 2. You are supposed to load 2 in IO0 DIR register. So this is all about using the IO0 DIR register. So by keeping this concept, we will be moving on to the next set of a register, that is set registers. Okay, IO0 set and IO1 set. So these are the 2 registers that are available. So these registers are used to set the pins in port 0 and port 1 respectively. Okay, you can make any of the pins either to set or reset. So example, to set all the pins. So set means you all know that you have to make that pin, or that pin should have logic high. If you want to make this pin to hold logic high, then you have to use IO set register. Okay, if you want to make this pin to hold high, or if you want to make this particular pin to hold high, why I have to make high? Because I'm connecting some external device here. Okay, I'm connecting some external device here. Let me choose it as an LED diode here. If I'm connecting diode here, and if I want to make that diode to be enabled, obviously I need to give logic 1 here. If I'm not giving logic 1, this diode will not be active. So therefore, in order to active this diode, or in order to enable this diode, I have to continuously pass a logic 1. For that purpose, I am giving a set value to this pin. So how to give the set value to this pin? By using the IO set registers. Okay, so there are two registers again, that is IO 0 set and IO 1 set. So these registers are used to set the pins in port 0 and port 1 respectively. So as we have seen with respect to the direction register, so the set registers are also available separately for port 0 and port 1. So if I am loading 0xFFF into IO 0 set register, so what happens? All the pins of which port? All the pins of port 0 is having logic high. Okay, example to set all the pins of port 1. So if I want to make all the pins of a port 1 to hold logic high means, then I will be loading this content into the IO1 select. And to be more specific, example to set the pins, that is from P0.0 to P0.3 of port 0. So if you want to make only the pins, that is from P0.0 to P0.3 to work or to make it as a logic high, then I'll be choosing F here. Okay, so F will be loaded into the respective register. Example to set the pins only P0.1 of port 0 means I'll be using 0010 and 2 will be loaded into IO0 set register. All right, so I'll be asking a simple question. I want all of you to answer in the chat box. So if you want to set the port P0.7, okay, if you want to set or if you want to make that particular pin has high, which register you will load and what content you load? I repeat once again, if you want to make high or if you want to set the port 0.7, which register and what data you will load into that register? I want to answer from all of you. So you have to try. So you may feel that I have understood the concept, no need to give the answer. It is the wrong way of thinking. You may understand now, but after some time you may forget it. So that's why try. I think you have a sheet of a paper. Try and give the answer in the chat box. I repeat the question. If you want to set a P0.7, which register and what data you will load? Soon. It's a very simple question. Yes, correct. Bhavya, P0.4 means you have to load 8. Okay.
Yes. Yes, sir.
Nothing. Do not think that I have given the wrong answer. Okay. So 0, 0, 0, 0, 0, 0, 0 and 1. So this is for P0.0 and this is for P0.1, P0.2 and this is for P0.3, this is for P0.4, this is for 5 and this is for 6 and this is for 7. Okay, if you want to make the P0.7, okay, if you want to make a P0.7 to go high, which register you will use is, obviously you will be using IO set register and what data you will be loading is 0x 00000080. Okay, this is 8, right? So this is 8 and this is 0. Okay, So 80 will be loaded into the IO0 set register in order to make the P0.7 to go high. Fine. So a few more examples are there. You can just analyze it. I'll be sharing this contents once after the completion of this lab. I'll be sharing it. So the next registers. Okay. So if there is a separate register for setting, means obviously there should be a separate register for clear also. If I want to make a particular pin to go low, or if I want to make a particular pin to hold a 0, then I have to use a set of a register called as IO0 clear and IO1 clear. Okay, this is not 10, it is IO0. Input output, 0 represents a port 0 and 1 represents the port 1. CLR is the register name for clear. Okay, so these registers are used to clear the pins of port 0 and port 1 respectively. So example, to clear all the pins of port 0. If you want to clear, or if you want to make all the pins of port 0 to hold logic 0, means you have to make all the pins as high. Remember, if you want to load zeros into the pins, you have to load 1 into the IO0 clear register. Okay, see here, FFF are used in order to make those pins to hold a logic 0. And here, example, to clear all the pins of port 1. Okay, they are using IO1 clear register. Example, to clear the pins that is from P1.0 to P1.3 of port 1. Obviously, you need to use IO1 clear register, and these pins will be taking the position the last 4, so that's why it is F. And the next example is to clear the pin P1.1, means then you have to choose this register and the contents will be 2. Okay, just analyze it. Whatever we have discussed with respect to the set, the same concept, but here in order to load the contents 0, okay, you have to use the registers called IO0 clear and IO1 clear for port 0 and port 1 respectively. So till here, what are all the registers we have discussed? We have discussed about the pin select registers. And how many pin select registers are there? Totally 3. Pin select 0, pin select 1 and pin select 2. And the next type of a register we have discussed about the direction register. So which will tell which port is an input and which port is an output. So there are 2 types of registers under the direction registers, that is IO0 DIR and IO1 DIR. IO0 is for port 0 and IO1 is for port 1. Next, we have the 2 types of registers which are responsible for setting and clearing the pins. So for setting, we have again 2 registers, that is IO0 set and IO1 set. For controlling again the 2 ports, port 0 and port 1. And again we have the clear registers, that is IO0 clear and IO1 clear, in order to clear the pins of port 0 and port 1 respectively. So I hope you have understood all the 4 types of registers in detail. Do you have any questions to ask me? Do you have any questions regarding any 4 types of registers? See, if there are no questions, means you would have understood completely, or you have not understood anything. So I hope everyone has understood about all 4 set of registers, right? Yes, no. Any one answer from everyone?
Yes, sir.
Yes. What about others? Yes. Dhanush understood, Ananya understood. Then what about
Yes,
others?
sir.
Yes. See, why I'm asking these questions in between is, these concepts are very difficult, and without understanding the basics, there is no point of explaining the programs with respect to the part B. Hence, we are asking the questions again and again. Fine. So now we'll just understand a very simple program. Okay, a very simple program we'll try to understand. If you understand this, then it will be very easy to understand the logic of part B experiments. So now this is a core, that is LPC2148. So for which pin? For P0.9, I'm connecting the I'm connecting the LED. LED is nothing but a light emitting diode. So this arrow marks indicates the light is emitted by this LED. So where I'm connecting this LED to? I'm connecting the LED to P0.9. Okay, to turn on this, one has to be provided to anode terminal of LED. Okay, so I want all of you to answer to the questions. Okay, so first of all, if I want to make this P0.9, okay, now I'm connecting this LED to P0.9. So first you give me the answer whether I have to make this P0.9 to work as a general purpose input output or transmitter or interrupt handler or pulse width modulator. Yes, tell me. So whether I have to make this register to work as a GPIO or other functions. As I have already told you, all the ports or all the pins should have to work as a GPIO only according to the syllabus. Okay, so therefore, so this P0.9 also have to make it as to work as what function? GPIO only. So therefore, which register you will consider? You will consider pin select register. And which pin select register? Pin select 0 you will consider. Okay, 0x, and let us not bother about what contents to load here. Okay, so now coming to the direction register, whether you need to make this particular port as an output port or as an input port. So before telling the answer, I will give you the hint how you will be deciding that, so this port to be an output or to this port to be an input. So now this is a peripheral. Okay, this LED is a peripheral. So if I'm giving contents to the LED means that is then this pin has to work as an output. If LED is giving something to the LPC means then this pin has to work as an input. So now according to this connection, I have to give logic 1 to this LED in order to get enabled. So now you just tell me whether I have to make this pin as an output or input. You just think about a single concept, whether LPC is giving to the peripheral or whether peripheral is giving to LPC.
Output, sir.
Yes, you have to make this pin as an output pin because this pin is giving something to the peripheral. Peripheral is not giving anything. Okay, so this LPC is only giving something to this peripheral or the LED. So therefore, I have to make this as an output device. Okay, we shall not bother what contents we have to load it here. Okay, so now one more question. If you want to turn on this LED, okay, you have to obviously pass 1 here. If I want to pass 1 here, whether you will choose a IO 0 set or IO 0 clear. Always 1 should be there in this pin. 1 should be loaded in this pin. So for such purpose, whether you will be using the register called IO 0 set or IO 0 clear. Fast. It's very simple answer. Why I have to give 1 here? All you know that if you want to enable this LED, okay, positive terminal, this is a positive terminal. Positive terminal should be loaded with a logic or positive voltage, and the negative terminal should be loaded with a ground or a negative voltage. So then only this will be enabled. So for such purpose, I will be loading some voltage here, that is a positive voltage. So I shouldn't give 0, I have to give 1 only. So if I want to make this pin to go high, which register you'll use, IO0 set or IO0 clear? Tell something. Only two registers are there. Whether you'll go for set or clear.
Set, sir.
Yes, you have to go for set. See, to get the answer of a single word, I have to shout so much. You are giving set, clear, like that. Anyway, be active. Fine. So now we will discuss a very simple program. Okay. If you understand this, then you will get to know how actually the programs will be there in the part B. So this will be the last slide. Okay. What is the example is LED has to keep on blinking continuously. LED has to keep on blinking continuously means the LED has to be activated and deactivated. Activated and deactivated. So activated and deactivated means what? You have to send 1 and you have to send 0. You have to send 1 and you have to send 0. So if you have to send 1, which register you'll use? You'll use set register. If you want to clear, you'll use clear register. Set register, clear, set, clear. Like that you have to use continuously in order to make this LED to blink continuously. Okay, so that is the logic of the program. So what are all the steps that we need to follow in order to blink the LED that is being connected to the LPC2148 is the first step is LED is connected to P0.9. This is not 10, sorry. See, in this diagram, I'm connecting the LED to P0.9. And do not think that I have to connect the LED only to P0.9. It is not like that. The peripherals can be connected to any of the pins that are available among 48. Okay, so LED being connected to P0.9, that is the first step. Okay, second step, make P0.9 to operate as GPIO. So that is the second step. You have to make that particular pin to function as a general purpose input output. So henceforth you have to make the pin select 0 as 0 0. So ninth pin means what? Ninth pin means what? The ninth pin means you have to make only 19th and 18th bit as zeros. Okay, only the 19th and 18th bit you have to make it as zeros, and rest of the pins we are not bothered because we are not connecting any peripherals to these pins. We are connecting LED only to the 9th pin. So therefore I have to make 19th and 18th pin to 0 0. But what I have written here, I have written zeros. I have loaded zeros for all the pins. So there is nothing harm if I am making all the pins as general purpose input output. Okay, instead of making only the 9th pin, I am loading all the pins to work as GPIO. Okay, and there is no compulsory that you have to load 0 only. You can make only the 18th and 19th pin to 0. Okay, rest it can be high also, not a problem. Next, the third step is make P0.9 to act as an output pin. Okay, as I have already told you, it is giving something to peripheral. So therefore you have to make that pin to work as an output. Okay, fine. Next, repeat for following steps. So if I'm connecting, okay, you can repeat these 3 steps continuously if you are connecting so many LEDs for all the pins. Okay, repeat the same steps. If I'm connecting LEDs to other pins means you can repeat the first 3 steps. If I'm not connecting any LED to other pins means then you can directly go for the 5th step. So on LED by writing 1 to the 10th bit. 10th bit means P0.9 is a 10th bit because it starts from P0.0. So P0.9 is nothing but you have to write a 10th. You have to write 1 in the 10th bit of IO0 set. So therefore I am writing 200 here. You can count it. Okay, 0 0. This 0 will be for first 4 bits, and this 0 will be for first next 4 bits, and this will be 5th and 4 plus 4 8 9 10th. So the 10th bit will be made it as high. So first I am giving 1, then I am introducing a delay, and again I am giving off. So what I am doing? First I am giving 1 here, so therefore LED is activated, and after a small delay I am giving 0, and after a small delay I am giving 1, and after a small delay I am giving 0. So therefore the LED will be completely blinking. So that is, have you understood the logic of the program? Still I have not went to the C language. I have just explained the steps. Is it clear, or do you want me to explain it again? Clear? Yes?
Sir.
Yes, sir.
Okay. And again, these three lines are normal for almost all the C languages, and we are using the library like lpc21xx.h. Okay, so you have to remember this lpc21xx.h. And now pin select 0 is loaded with 0, as I have already told you. You can make all the pins to work as a GPIO, or you can make a specific pin, that is P0.9, to work as a GPIO. And IO0 DIR, what content I'm loading into the DIR? I'm loading 200 here. Why I'm loading 200? Because the 10th bit, that is P0.9, or the 10th pin should be made as output pin. So therefore I'm loading 200 here. And while 1 means the condition will be always true. So therefore directly the processor can start executing, entering into the loop. So what I'm doing, I'm setting the value first. If I'm setting, the LED will be turned on. Then give a small delay, call for a function. The function is here. Okay, call for a function. After executing this function, again you clear it. So therefore the LED glows, LED will be off, and again give a delay, and again go back. So again the LED will be turned on, a delay, LED will be off. So therefore continuously the LED will be turned on and off continuously, right? Have you all understood the program logic? Yes, no?
Yes, sir.
Okay,
Yes, sir.
fine. So if you have understood, I request the Srivatsa team to present now. Srivatsa. Srivatsa is here.
Yes, sir. 1 minute, sir.
Okay. I'll stop sharing. Sure, I'll share the recordings.